Hi guys, if you have questions, email me or write a comment. Hi again. Remember that we talked about definite integral and what does it mean? Let me remind you that definite integral means area under a curve. So if we said we have a function from a to b, then the integration of f of x from a to b, depending on x, means the area under the curve and between the curve and the x-axis. So keeping that in mind, we have properties of definite integral. What are the properties? The first property, according to this definition, it says integration from a to a of f of x dx equals. I believe that you can figure that out. If I'm talking about a to a, this means I'm talking about same line here, so there is no area, so this should be equal to 0. Or you can figure that out from the way of calculating this. We said that this integration will be equal to capital f of b minus capital f of a, so it will be equal to f of b minus f of a. Since I'm talking from a to a, so it will be f of a minus f of a, which is 0. So that makes sense. Now, what is the second property here? Second property says integration from a to b of any function is the same as integration from b to a of the same function, but it should be negative. Does that make sense? Of course. According to this, if I'm normally doing b minus a, then if you do a minus b, that will be the opposite sign. And that is what this rule says. So if you have integration from 1 to 2 equals 5, then from 2 to 1 will be equal to negative 5. Third property, it says integration of any constant times a function from a to b, and also this one works for indefinite integral, not only for definite. What would this be equal to? Remember that we said about what we said about the area here. How did we figure out what is definite integral? It was by taking a limit of number of rectangles. So integration is actually a limit. And what was the property of limit when we have constant times a function? It was taking the constant outside. So we can apply the same thing here. So this will be the constant times integration from a to b of f of x dx. And keep in mind, this property works also for indefinite integral. So even if you have boundaries like a and b, or if you don't have, you can still take the constant outside the integration. And for the same reason that it is a limit, you can also apply it on addition and subtraction. So if you have f of x plus or minus g of x, then you can distribute the integration over addition and subtraction. So this will be integration of f of x from a to b plus or minus whatever the operation is, integration from a to b of g of x dx. Is that all? Actually, no. Since it talks about area, so if I have an integration from a to b of f of x dx, it can be separated. How is that possible? Let me show you this. Let's say that we have this integration of these two areas. Let's say that we have this triangle, for example, and this rectangle, let's say, and it was from A to B. How would you find the area of this combined figure? For sure, you would say, I will find the area of the triangle, then I will find the area of the rectangle. Well, that's right. Sorry, as long as you are using this number here. So let's call it C. So integration from A to B of f of x dx would be equal actually to the integration from A to B plus the integration from A to C, sorry, plus the integration from C to B. So this can be simply be written as integration from A to C f of x dx plus integration from C to B f of x dx. What does this mean? This means that you can separate any integration into addition of two integration as long as you are using the same common number, C here. You are starting from A, and you are adding with B, using a number, the same number for both integration. Okay, would that be helpful? Of course that would be helpful. What else do we have? Actually, we have, and let me just give you an example before we move on. An example on this. Let's say we have an integration from 1 to 2 f of x dx equals 3. That's given. And an integration from 2 to 4 f of x dx equal 7, for example. And I'm asking you to find integration from 1 to 4 of f of x dx. Note that in this example, f of x is not given, so you cannot evaluate it. You have to depend on the given information. So what do I have here? 1 to 4. Do we have anything in the function that can help me? Yes, I have the beginning 1 here, and I have the end is 4. Do I have a common number? Yes, there is 2 here, and there is 2 there. So this can be done as from 1 to 2 f of x dx plus from 2 to 4 f of x dx, which means the answer of this integration is from 1 to 2, which is 3, from 2 to 4, which is 7. So it will be 3 plus 7, which is equal to 10. Okay. These are 5 main properties. We still have one more property, which is a comparison property. What does a comparison property say? It says if f of x is less than or equal g of x on a certain interval like a, b, then for sure the integration from a to b of f of x dx should be less than or equal the integration from a to b of g of x dx. I'm talking about the same interval here. What does that mean? If I have two functions, for example, you have two functions. One of them is f, and the other one is g, for example, here, g, and you are looking for the area between A and B. What does that mean? This means this is the area that I'm talking about. So the area under curve F is less than the area under curve G for this interval. That's obvious and makes sense. These are the properties of definite integral. I hope that you got that. Later on, I will post some practice on this. Remember to like, share, and subscribe, and write your questions via email or comments.